Good morning, students. Myself, Vijay Shankar from ECE Department, Chapter Engineering College. Today, we are going to discuss about the last topic as your syllabus in the JNTUK R19 for the second year ECE students. The fifth unit is EM wave characteristics, electromagnetic wave characteristics. In previous classes, we discussed about the electrostatics and the magnetostatics and the Maxwell's equations also for the time varying fields. Now, in this unit, we can see the electromagnetic wave characteristics. So, general equations. To find the general wave equations, let us assume the electric and the magnetic fields exist in a linear, homogeneous, and isotropic medium with the parameters mu1, epsilon, and the sigma. So mu is a permeability, epsilon is a dielectric constant, permittivity, and the sigma is a conductivity. Also assume that the medium is a source-free, which clearly gives the idea about the charge-free medium. Assume that the medium obeys the Ohm's law, G bar is equal to sigma into E bar. The current density, the J bar is equal to sigma into E bar. Then the Maxwell's equation, one of the Maxwell's equation, the del cross E bar is equal to is Maxwell's equation of the Faraday's law minus dou B bar by dou T. Dou B bar by dou T. The relation between of B bar and the H bar is B bar is equal to mu into H bar. Substitute the B bar as a mu H bar minus dou by dou T of mu into H bar. So mu is a constant, we write the outside minus mu into dou by dou T of H bar. Okay, my dear friends. So we got that from the Faraday's law of Maxwell's equation, del cross E bar is equal to minus mu dou by dou T of H bar. The second one is one of the Maxwell's equation, that is from modified Ampere circuit law. Del cross H bar is equal to J bar. The J bar is a combination of the conduction current density, JC bar, and displacement current density, JD bar. JC is equal to conduction current density, opposite Ohm's law. The Ohm's law, the JC is equal to sigma into E bar. Plus JD bar is a dou D bar by dou T. Dou D bar by dou T. And the second term also you can write it as in terms of the E bar, epsilon into dou E bar by dou T. Dou E bar by dou T, because the D bar is equal to epsilon into E bar. Epsilon is a constant right outside in the dou D bar by dou T of E bar. Okay, so del cross H bar is equal to sigma into E bar plus epsilon into dou E bar by the dou T. This is from Faraday's law and Ampere's law. These are the two Maxwell's equations. Another Maxwell equation, Gauss law of magnetic field. Gauss law of magnetic field, del dot B bar is equal to 0, and the relation between of del B bar and the H bar, del dot B bar is equal to 0 means del dot H bar is also the 0. Gauss law of magnetic field. Gauss law of magnetic field. And second one here, the last Gauss law of electric field. Gauss law of electric field, electrostatic sphere, del dot B bar is equal to rho V. Del dot D bar is equal to rho V. In the rho V, in the free space, rho v is always a 0, my dear students. So del dot d bar is equal to 0. That is del dot d bar is also the 0. Okay, the four Maxwell's equation here. When we consider it is a free space, the source is a free space, charge-free medium. Charge-free medium. Rho v is equal to 0. And actually the conductivity is also the 0. Then to eliminate the h bar from equation 1, to eliminate the h bar in the equation 1 here, see the first one. Take the curl on both sides in the equation to get, for the first equation, take the curl function. Del cross E bar is equal to del cross E bar is equal to minus mu is a constant. Del cross dou H bar by dou T. Both sides you can take as a cross product. Del cross E bar is equal to. When del operator indicates a differentiation with respect to space, while dou by dou T operates a differentiation with respect to the time. Both are independent of each other. The operators can be interchanged. Del cross E bar is equal to minus mu into dou by dou T. You can write this outside. Both are the same, my dear students. So del cross dou H bar by dou T is equal to, you can write it as a dou by dou T of del cross H bar. Del cross H bar. So the left hand side del cross E bar is equal to minus mu dou by dou T of del cross H bar. And substituting the value of del cross H bar from the equation 2 we get. So what is the del cross H bar here? Sigma into E bar plus epsilon into dou E bar by dou T. Substitute the del cross H bar in this sixth equation. Del cross E bar is equal to minus mu dou by dou T of the del cross H bar sigma into E bar plus epsilon into dou E bar by dou T. Okay. So del cross E bar is equal to minus mu into sigma is also constant, write it outside, dou by dou T of E bar minus mu into epsilon, multiply with the dou by dou T here, the dou square E bar by dou T square. From the curl properties, del cross E bar is equal to, or according to the vector identity, del of del dot E bar minus del square E bar. Okay, in this, the del dot E bar is equal to 0. Del dot E bar is equal to 0 means the first term is a 0 here. See, here the del dot E bar is equal to 0. Substitute that del dot E bar in the curl property. Del dot E bar is equal to 0. Del dot E bar is equal to 0. The first term is a 0 means del cross E bar is equal to minus del square E bar. Minus del square E bar is equal to, again, minus mu sigma dou E bar by dou T minus mu into epsilon dou square E bar by dou T square. Got it, my dear students? I substitute here del cross E bar is equal to del of del dot E bar minus del square E bar. So del dot E bar, according to the Gauss law of my electric field, the rho v in the free space, the rho v is equal to 0. Del dot E bar is equal to 0. The term only we have minus del square E bar in the left hand side. So minus mu sigma dou E bar by dou T becomes a minus into minus is a plus. Remove the minus on both sides. Plus mu into epsilon dou square E bar by dou T. This is the equation for the electric field E bar. Del square E bar is equal to mu into sigma dou E bar by dou T plus mu epsilon dou square E bar by dou T square. Okay. Now multiplying the both sides of the equation 10 with epsilon r, or it is epsilon del square epsilon E bar is equal to mu into sigma, means it simply change that E bar as a D bar. The relation between of E bar and the D bar is that D bar is equal to epsilon into E bar. Epsilon into E bar. Okay. So take the epsilon here, the del square, epsilon into E bar. I'm multiplying in the left hand side with the epsilon, and the right hand side also the mu into sigma dou epsilon into E bar by the dou T plus mu. Already here the epsilon is there. Write that epsilon inside. The epsilon into dou square, here also the epsilon into E bar by the dou T square. So using this relation, epsilon into E bar, wherever the epsilon into E bar, you can replace the T bar. Del square T bar is equal to mu into sigma dou D bar by dou T plus mu into epsilon dou square D bar by dou T square. Okay. Now this is the equation. This is also the wave equation for the D bar in the uniform. Okay. Del square E bar is equal to, this is a waveform equation, the wave equation for the electric field intensity E bar, and this equation is the wave equation for the okay, my dear friends, so this is the equation for the electric field E bar, and this is a wave equation of for the D bar in the uniform medium. Okay. Exactly on the similar lines, the wave equation for H bar can be obtained by taking the curl on both sides of the equation. The two. Previously, to get the equations of the wave equation for the electric field and the wave equation for the electric flux, we take the equation 1. Now we can take the equation 2, the modified Ampere circuit law. Del square H bar is equal to, and del square H bar is equal to not the del square H bar is equal to del cross H bar is equal to sigma into E bar plus dou D bar by dou T. Dou D bar by dou T. So take the cross on both sides, curl function, del cross H bar is equal to, for the first function, del cross sigma into E bar plus change is a D bar as a E bar, epsilon into del cross dou E bar by dou T. Dou E bar by dou T. Modify the right hand side equation, del cross H bar is equal to sigma is a constant right outside, the del cross E bar plus here also the epsilon dou by dou T of del cross E bar. Dou by dou T of del cross E bar. Now you can see here, as a del operator and the dou by dou T represents the independent relationship between the two, we can interchange as follows. Del cross H bar is equal to sigma into del cross E bar plus epsilon into dou by dou T of del cross E bar. Okay. Now what is a del cross E bar is equal to? From the equation 1, you can say del cross E bar is equal to, we substitute that value, minus mu into dou B bar by dou T B bar is changes as in terms of H minus mu dou H bar by dou T plus epsilon into dou by dou T of and del cross H bar is also now represent the dou mu dou H bar by the dou H bar by dou T. That is equal to the left hand side is the same minus mu sigma dou H bar by dou T, and here also the minus mu epsilon dou H bar by dou T. Got it, my dear friends? From the vector identity, the left hand side equation becomes del of del dot H bar is equal to, not is equal to, minus del square H bar. Del of del dot H bar is equal to, write the H bar dot H bar minus del square H bar is equal to minus mu sigma dou H bar by dou T plus mu epsilon dou H bar by dou T. Simply, it is a simplification only, my friends. So del cross H bar is equal to del of del dot H bar minus del square H bar. We know the del cross del dot H bar and del dot E bar is both are the zeros. Now the first term here, the 0 minus del square H bar is equal to minus del square H bar is equal to the right hand side also this both the equations minus mu, here the minus, my dear students, all the minus is there, is a minus sigma into dou H bar by dou T minus mu epsilon into dou H bar by dou T. So take all, it is a plus and plus. Del square H bar is equal to mu sigma dou H bar by dou T mu epsilon dou square. Why it is a dou square means you can take mu epsilon, it is a dou only, my dear students. There is no any dou square, dou H bar by dou T only. Del square H bar is equal to mu into sigma dou H bar by dou T plus mu epsilon into is the equation we have the dou H bar by the dou T. Okay. There is no change here in the left hand, right hand side. Whatever we got here, the minus is becomes a plus. All the minuses on. Similarly, the H bar and H bar convert into the B bar. The value is B bar is equal to mu into H bar. So wherever the mu H bar is there, you can multiply with the mu, becomes of del square mu into H bar is equal to mu sigma into dou mu H bar by the dou T plus mu epsilon into dou mu H bar by the dou T. So replace wherever the mu H bar with B bar. So del square B bar is equal to mu sigma into dou B bar by dou T plus mu epsilon into dou B bar by dou. So now it is converted into the waveform of the magnetic flux. Del square H bar is a waveform equation of the magnetic field. Got it, my dear friends? So del square mu H bar is equal to mu dou by sigma into dou mu H bar, and the dou square, it is not the dou square, my dear friends, dou only. It is dou mu h bar, and here also the dou h bar by dou t only. And keep the mu h bar as the b. Del square b bar is equal to mu into sigma dou b bar by dou t plus mu epsilon into dou b bar by the dou t. This is the equation for the d bar in the uniform plane. Not the equation for the d bar. It is a b bar, my students, in the uniform medium. Hence, in general, we can write it as L square E bar, D bar, H bar, B bar. All the equations. Mu epsilon into it is a E bar, D bar, H bar, and the B bar plus mu epsilon into dou by E bar, D bar, H bar, and the B bar. About the three-dimensional equation for all the field vectors. Got it, my friends? Now we go for the uniform plane wave in a free space. The actual topic in the electromagnetic waves characteristics. In that, first one is a uniform plane wave in the free space. Free space means it is a dielectric constant. Is compared to the conductivity is a mode. Sigma is very much less than the omega epsilon. Okay. We know the JC bar by the JD bar. The magnitude of JC bar by the JD bar is very much less than the 1 and very much greater than the 1. JC is the sigma by the omega epsilon is very much greater than 1 and sigma by omega epsilon very much less than the 1. This is the second condition. The free space means sigma is very much less than the omega epsilon. Okay, means conductivity is very less compared to the dielectric. So as I assume an electromagnetic wave traveling in the free space, consider that an electric field is in the x direction while the magnetic field is in y direction. Both the fields will not vary with the x and y. Remember this, my dear students. Assume that the electric field is in the x direction, so Ex bar, and magnetic field is in the y direction, Hy bar. Both the fields will not vary with x and y, will not vary with respect to, means dou Ex by the dou x is equal to 0. It is not vary with respect to the y also. Even the dou by dou x and the dou by dou y, all these terms becomes a 0. Only it is varies with respect to the z only, means dou Ex by the dou z. With respect to the z only, it varies. The remaining dou x or the dou y with respect to the values of the 0. They will also change the time as the wave propagates in the free space. Okay. Now consider the Maxwell's equation. Consider the Maxwell's equation expressed in E bar and H bar. That is one of the Maxwell's equation, Ampere circuit law. Del cross H bar is equal to JC bar plus JD bar, where JC is conduction current density and JD is the displacement current density. Since it is okay, you see both the fields will not vary with respect to the x, with respect to the y, and but with respect to the z only it varies, and they will also change with the time as the wave propagates in the free space. So here consider the Maxwell's equation expressed in the E bar and H bar. Del cross H bar is equal to J bar plus dou D bar by dou T. In a free space, it's a perfect dielectric. The conductivity is 0 because J bar is equal to sigma into E bar. The sigma is the conductivity. If conductivity is 0, J bar is equal to 0. Del cross H bar is equal to dou B bar by dou T. Dou B bar by dou T. Now, expressing the d bar in the rectangular coordinate system, rectangular coordinate system. Del cross H bar is equal to, we know, dou B bar, dou D bar by dou T. The D bar in the rectangular coordinate system, dx ax bar plus dy ay bar plus dz into az bar. Represent that D bar as in a rectangular coordinate system having the x term ax bar plus y, the dy into ay bar plus dz into az bar. Okay. So del cross H bar is equal to dou by dou T of this D bar replaced with the rectangular coordinate system, and write the curl function on the left of the equation as see the curl function means in the right hand side we have the D bar is equal to this function, and ax bar as a curl del cross H bar, ax bar, ay bar, and az bar, and it is a dou by dou x of and dou by dou y and dou by dou z, and h value is a hx and hy and hz is a del cross H bar. First of all, you can take the ax bar as dou by dou y into hz or dou hz by dou y minus, and this cross multiply here, dou hy by the dou z into ax bar into ax bar. This is the first term understood here. The second term axy bar means dou by dou x of hz, dou by dou x of hz minus dou hx by dou z into the second term means you can write as a minus of ay bar. Multiply the minus here, dou hx by dou z minus dou hz by dou x into ay bar. And the last term, you can see the last term az. Az means these two functions you can multiply. And is dou by dou x of hy minus dou hx by the dou y into az bar. Okay, dou hy by dou x minus dou hx by the dou y into az bar. Okay, this is the del function. Del cross H bar is equal. What we are saying with respect to the x, with respect to the y, it is not varying. Means wherever it is with respect to the y here, the value becomes a 0, and with respect to the x is also the 0. With respect to the x, it's also 0. With respect to the y is also 0. Only it is varies with respect to the z only. So as a h bar is in y direction, hx and hz is equal to 0. Hx and the hz is equal to 0. Hx is a 0 and hz is also 0. And we are saying that it is not varying with respect to the x and y also. Okay, h is in the y direction and e is in the x direction. So h is in the y direction means hx and hz is equal to 0. All the terms what we have here, the hx and hz is all the zeros, and the hy is there, and here the hx. But with respect to the z is varying, hx is equal to 0 means this term is also 0. This term is also 0. So finally, the minus dou hy by dou z into ax bar plus dou hy by the dou x. Okay, hx is also the 0. This is when the hx is depends. And with respect to the x, it is not varying, so we are not considering this function also. Also, hy is not changing with respect to the x, as it is a uniform in xy plane. So dou hy by dou x is also 0. So we have only the one term in the left hand side, that is the minus dou hy by dou z into ax bar is equal to right hand side function dou by dou t of dx ax bar plus dy ay bar plus dz and az bar. Okay. Now, in the left hand side, the ax bar is there, and in the right hand side also we have the comparing the ax bar only minus dou hy by dou z is equal to dou dx by dou t, because these two are ay direction and az direction. So finally we have the dou hy by dou z is equal to dou dx by dou t and minus dou hy by the dou z is equal to, change this as in terms of the electric field, epsilon into dou ex by the dou t. Got it, my dear students? So one equation we got. Minus dou hy by dou z is equal to epsilon into dou ex by dou t. And second Maxwell's equation of another Maxwell's equation from the Faraday's law, del cross E bar is equal to minus dou B bar by dou T. Similar fashion, you can write this equation. You'll get dou del cross E bar is equal to, you can write AX, EY, AZ, and del is dou by dou X, dou by dou Y, and dou by dou Z. E bar is EX and EY and the EZ. So whenever if it is in the EX is in the X direction, EY and the EZ is equal to 0, and it's not with respect to the X and with respect to the Y is also the 0. Only with respect to the Z it is varies. Using these conditions, you can find out the del cross E bar is equal to minus dou B bar by dou T also.